Hi, we're going to take a quick look and break this into a few different videos, so be prepared to stop. We're going to talk about mass first. Mass versus weight. We talk about how many pounds we weigh. In science, we use how much mass is inside of us. So weight is the force of gravity on you. It's not the same on Earth as it is on the moon. The moon has about a sixth the gravity of Earth, and therefore it has the sixth of our weight. So, and Mars has about a third of our weight. So, either way, you'd actually weigh less. But mass has to do with how much is packed inside of us or inside of an object. And mass is consistent no matter where you are, whether you're on the moon or Mars or the Earth, your mass stays the same. So, science likes to use mass because it's consistent if I'm on the space station or if I'm on Earth or if I'm on the moon, it's all the same. So, the force of gravity pulling you down is your weight. Um, and in science, weight is actually a force, so it's actually something called a Newton, which will make sense in another couple of units when we find out about force units. In the US standard system, it's pounds. So objects are attracted, remember, downward by that pull of gravity, and therefore that has to do with our weight. Again, weigh we less on the moon than we do here. Scientists don't use weight because, again, good test question, it's not the same everywhere, but mass is. So, when you are done with this, you should go watch this movie. It's a really quick one reminding you about the difference between what is a kilogram. In fact, maybe we'll just watch it. Here we go.
Mass is a measure of the amount of matter in an object. The basic unit of mass in the metric system is the kilogram. To measure the mass of small objects, we use the gram. There are 1,000 grams in a kilogram. To give you an idea of the gram, a paper clip has a mass of about half a gram. A ballpoint pen has a mass of almost 5 grams, and a cup of water has a mass of about 250 grams. On Earth, a 150-pound person has a mass of 68 kilograms. Now don't confuse mass and weight. Mass is the amount of matter something has, while weight is a measure of the attraction that gravity exerts on an object. Because the mass of the moon is about 1/6 that of the Earth, the person who weighs 150 pounds on Earth only weighs 25 pounds on the moon, but still has a mass of 68 kilograms.
Okay, that should sound really familiar for what we just talked about. By the way, she said 68 kilograms because 1,000 grams is a kilo. So she just changed the 68,000 grams into 68 kilograms. All right, I'm going to go through a couple questions with you, not all of them, but we're going to go through a few, so it's probably worth your while to watch these videos. I just want to make sure we've got some of this basic information down. So what tool are we going to use to measure mass? Mass remembers how much stuff is inside something. Well, a meter stick measures length. A graduated cylinder like this one measures volume of a liquid. A triple beam balance sounds promising, but let's just double check it. Let's look at the D. Thermometer measures temperature. So the only one left that would make sense is a triple beam balance, which is what we'll look at shortly on how we actually find the mass of things. So our answer is triple beam balance. What is the basic unit of mass in the metric system? Liter is volume. Pound is not metric. Do not pick pound. Meter is length and gram is mass. Okay? Okay, now we're going to look at, and that video might be a good thing to go back and revisit for this one if you're having trouble with it. The amount of soda in a can. Well, all of these are grams, so we know our base unit is grams because we're looking for the mass of each thing. So what would be the best thing to find the mass for each of these? The amount of sodium. So how much salt is in a can of pop? Well, we've got milligrams, which are small. Centigrams, think of that as like the dime size. A penny is to a milligram as a dime is to the centigram, which actually is kind of how it goes because it's base 10. And grams are, there's 1,000 milligrams in a gram. There are 10 milligrams in a centigram. And the one that's not in there, a decigram, there's 100 of those. So in this case, probably if you're looking at salt in it versus the whole can of pop, that might be different. But we're looking at salt, we're probably going to go for the milligram. Your mass, well, a centigram, probably not, because if grams, I mean, look at the weight we did up there, 68,000 grams. That's not something we want to say. We divided by 1,000 and went to 68 kilograms. So your weight is probably going to be the kilogram. Now, the mass of 10 pennies and the mass of a Mini Cooper, I'm going to let you figure those two out. Let's go down and look at this triple beam. I'm going to make it just a little bit larger. And actually, we use triple beams. This is actually a 4-beam balance because it separates the hundreds back here, and then the tens, and then the ones, and then the tenths. So really all you do is you just add up what's highlighted. There are 0 hundreds, there are 40 tens, there are 40 plus 7 ones, so 47, 47.5 something, right? And it looks like it's somewhere, it's a little hard to tell, but the answer will be pretty obvious. 47.52 maybe? And look down here, the only one close to that is 47.52. Now here's another one. I'm going to have you work on this one, and I'm pointing straight to the numbers I want you to do. Here's our hundreds, our tens, our ones, and our tenths. Pick your correct answer. This is our actual triple beam that we would be using in school, and this is my handy dandy octopus that one of my students made for me last year on the 3D printer. So we took this and we found its mass, and I did that by using a triple beam, and I took a photo of it. You'll notice that it weighs less than 100 grams, but it weighs at least 20 plus a little more because I've got some ones down here. And you're going to notice that if you look at this, I've got 20, and these are ones and tenths, so 25.1. It's almost right at the one. It's actually, I could even go 25.5 for that, but go for the one that's the closest, in this case 25.1. Okay. Keep looking up and figuring out the mass of certain objects, and when you're done with that, we're going to go on to the next unit. Again, just more reading triple beams, and now we're doing some conversions that you did from your metric practice. So how many 16 milligrams is how many grams? Figure that out for me, please. And then when you're done with that, come back and we'll watch the volume.